Hello class, today I'm going to teach you about linear inequalities. The first thing to remember about inequalities is that if you ever multiply or divide by a negative, you need to flip the inequality sign. Now besides this, there's not too much different with solving. We are going to talk about a few things with notation though. If you remember, in the past when you've had inequalities, a less than or a greater than sign you would graph with an open dot, and a less than or equal to or greater than or equal to you would graph with a closed dot. Well, now we're going to start talking about a different type of notation where less than and greater than is going to use parentheses, and when it's or equal to, you're going to actually use square brackets. With that, infinities, the negative infinity sign and positive infinity sign, always get parentheses. This new notation is called interval notation. The old notation was called set builder. So let's take a look at some of the graphs of things that you've seen before. So this first one shows an arrow with going to the right off of the number 3. So before, you would represent that as x greater than or equal to 3. Now, the way that you would write that is you're starting at 3 with a closed dot, so you're going to start with a bracket, and it's going all the way out to the right forever, ever, 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 which would be to infinity. And infinity, like I was saying up here, is always going to get parentheses, so you're going to close it with a parenthesis. Okay, the second one has an arrow going to the left with an open dot. So you would write this before as x is less than negative 2. Now, you actually have to think left to right. So way left over here is negative infinity, which gets a parenthesis, and we're going to the right until we get to negative 2. Oops. And that should finish with a parenthesis as well because it's an open dot. The last one is what I call a barbell graph. You're looking at it between negative 1 and 3, so how I usually do it is put the x in the middle and make two signs that look like L's. We have a solid dot at 3 and an open dot at negative 1. So this is how you used to write this. Now, it's actually easier. You're just going to do it parenthesis for negative 1, comma 3 with a bracket. Okay, now let's try some where you actually have to solve. So the solving is pretty much like normal. I'm going to start by adding over the 5. 3x is less than or equal to 18. Divide by 3, and we get x is less than or equal to 6. So the solving part I know you can do. Now the graph, when we start this, we're going to start with a number line. Whenever you do a number line graph for me, I'd like you to put on 0 and then the critical number, which in this case is 6. You would graph this with a closed dot at 6 and an arrow going to the left. Now, how we're going to do that now is instead of using the dots, we're going to use parentheses and brackets. So I would have a bracket on the 6 and my arrow going to the left because that's where the less thans are. The reason I made my line squiggly here is just so that you could see it on top of my number line, but of course that should just be a solid line. In interval notation, your answer would be negative infinity, comma 6 with a bracket. Okay, let's go ahead and solve number 2. So I'm going to start by distributing my negative 5. Three x minus 5x is negative 2x, and I'll add the 10 over. Now, I'm dividing by a negative, so what do you have to remember to do? Flip the inequality sign. I'm going to go ahead and make it a decimal, so x is greater than negative 8.5. Now I'll go ahead and put that on my number line. So here's negative 8.5, here's 0. Since it's just greater than, I'm going to use an open dot, which now means a parenthesis, and greater than means to the right. So a parenthesis, arrow to the right. In interval notation, this would be negative 8.5 to infinity. Alright, let's go ahead and solve the next one. For this one, in order to get rid of the negative 5 in the denominator, I'm going to multiply both sides by negative 5. That's going to get rid of my negative 5 on the left, and on the right I'm going to distribute. So I've got negative 20 plus 5x. Now I'll move my x's to one side, numbers to the other. Oops, and I changed it into an equal sign. So I'm going to get 7 is less than or equal to x. When you graph this, here's 0, here's 7. I should probably turn this around, so I'm going to say x is greater than or equal to 7. I have a bracket on 7, and my arrow's going to the right. In interval notation, this would be 7 to infinity. Alright, this next one looks a little bit different. Hopefully you've seen something like this before. When you're solving, you're just going to solve in 3 places. So when you're trying to get x by itself, the first thing you would do is subtract 4. So we're going to have negative 11 is less than 3x, which is less than or equal to 4. And then we divide by 3, again in all 3 places. So this is the kind of inequality that's usually going to give us that barbell type graph like we saw in the beginning. So if we graph this one, we've got negative 11 over 3, 0, and positive 4 over 3. And then when you're doing your marks, the negative 11 over 3 is going to get a parenthesis, and the 4 over 3 is going to get a bracket, and I'm going to shade right in between those two. My interval notation answer is going to look like this, negative 11 over 3, comma, 4 over 3 with a bracket.